Excited to have Jorge here today. He's going to be giving a talk on research strategy and operations in the era of open data and Gen AI. Going to pass over to him shortly here, but just to kind of go through the agenda for today, we'll start off with just some introductions, then we'll run through into the talk. I think you've got a presentation to share as well. Just as mentioned, this is going to be a conversational style thing, so feel free to come off mute, ask any questions, or put questions in the chat, and we will address them as well during the Q&A section too. So just very quickly, I'm Tome. I'm the host of this webinar series. I founded a company called Atom. We're building AI tools for the Research Development Office and pre-award. And yeah, I come from a kind of research background, but I've spent the last couple of years building tools to support the research ecosystem. And I came across Jorge's work. He's been working on very similar things, data visualizations. And I'll let him introduce himself. He'll do a much better job, but we're super excited to have him featured on the talk today. I've been following his stuff for a little while here, so super keen to learn more about it through this webinar. Jorge, do you want to say a couple of words about who you are?
Yeah, and in fact, I have one slide to introduce myself,
okay.
So I can.
Awesome. So let's shift over to your screen share, and you can take it away.
Okay. Can everyone see my screen? Yeah, perfect. So thank you, Tomer, for the invitation, and obviously thank you everyone for joining us. I have a couple of slides as a background. My name is Jorge. I am an independent consultant based in the UK and a senior research fellow around Europe. And I work mostly with research funders and research organizations, helping them make sense of the research ecosystems in which they are operating through data-driven analysis, as you'll see throughout the presentation today. I always give, in case there's any data scientists in the audience, I always say I do quite a lot of data science, but I'm actually a chemist by background, so I'm entirely self-taught. If you hear anything that is not quite right, probably that's why. I'm pleased to tell me if that's the case, or that something that you don't agree. That's what I should say. I'm going to tell you about work on using open data and generative AI to help with strategy and operations. But I'd like to start by laying out my theory of the case. I had a job that I quite enjoyed a couple of years ago, and actually I decided to go independent because I saw that there was quite a big need for the type of work that I've been doing. So I'm going to tell you in a couple of slides what's the need for this type of work. I think I've seen that most strategic funding decisions very often lack external evidence. A lot of funding decisions are done through gut feeling or with quite incomplete partial analysis. Part of that is because there's a massive data fragmentation across different platforms. It's very difficult to get all the information that you need in a single place. And when you can, it tends to be quite expensive. And generally, decision makers tend to be unaware of all the sort of the universe of analytical possibilities. This is something that's quite common both for funders and universities. There's a gap in that capacity to show how to go from output to outcome or from output to actual impact, basically to say what the research that you are funding or that you are producing, what is it actually accomplishing? Historically, I think there's been an overdependence on qualitative narratives to do that, because I think qualitative narratives are the gold standard to talk about impact and to showcase impact. But the problem is that you cannot possibly cover the whole ground that you have of these vast portfolios of entire universities or of entire funding bodies purely through qualitative approaches. And that's where some of the work that I'll be discussing later today can really help. And because of this, there's been a sort of the last few years, there's been some tools that have come up to, in theory, help with impact tracking or impact measuring. And in my experience, they tend to not do a great job at what they promise that they can do. And then the final thing is that what I've seen, I think this is especially true for smaller organizations. Organizations tend to lag behind technological advancements. A lot of this data work that I'm going to show you today almost no one has this type of capabilities in-house, and it tends to be seen as more nice to have rather than essential. And there's still quite a lot of skepticism about AI, which, and because I want this to be a conversation, if there's any AI skeptics today, it's something I would love to address or to discuss with you. The final point is that there's all these legacy processes that are simply collapsing under modern scale. And here I'm talking about all the manual workflows that are required to do peer review, for annual reporting processes, or for building case studies to share with your stakeholders. And this is where we need either new technologies or a change in the way things are done, a change of paradigm, or perhaps both of them. I'm not saying that technology needs to be the one and only answer to address these issues. So my answer to some of these problems is work with open data because it's cost efficient. You do not need to pay for expensive solutions. It means that you need to spend a little bit of time aggregating and harmonizing and linking information, but once you've done that, you are set. You don't need to you don't need to have an ongoing costly yearly subscription with some of these data research platforms. Everything I do tends to be enhanced by AI techniques and language models to achieve deeper insights quicker, to try to analyze that qualitative scientific information that I mentioned earlier at scale in a way that you can cope with it. And then, especially in this past year, I've been building quite a lot of scalable modular tools to basically try to automate, or not fully automate, semi-automate some of these processes that tend to be really labor intensive, or simply cannot happen under normal circumstances because of the scale of the problems. So in today's presentation, I'm going to tell you a little bit about some of the data sources that I've been using, a couple of the techniques that I use, and then I'll show you examples, very practical examples of the types of questions that you can answer through open data and through these advanced techniques. And I'll finish the presentation with just a couple of examples of these modular tools that I've been building. I'll start with working with open data, and I always show as an example, I don't know if you heard of Dimensions. Dimensions is a data platform owned by Digital Science. They're quite well known here in the United Kingdom, and I think they're great. They basically work with different data sources across the research ecosystem, and they link those data sources through unique identifiers. This is the platform that I used to use in my previous work, and I loved it. And when I started working on my own, at the beginning, I really missed it. So something that I spent the last couple of years is trying to recreate what I used to do with that platform entirely through open data, because this type of platforms like Dimensions tend to be quite expensive to work with and difficult on an individual level. So that you can, and basically what I'm saying is that there's good open source alternatives to essentially almost every single data source, be it publications, patents, clinical trials, that you can join through unique identifiers, ideally, like DOIs or grant IDs, or through some perhaps slightly more advanced techniques like name matching. And here I always give the example of if in one data set my name appears as Jorge Gomez Magenti, and in another one it appears as Jorge G. Magenti, it's the process of making sure that you know that those two things are the same. Or maybe not, maybe the name is exactly the same, but actually are different people. And the process of figuring that out and doing that disambiguation is quite interesting, and that way, that's how you can link together disparate data sources. There's essentially good openly available data sources for different types of documents, except in my opinion, grants was quite lacking. Normally, every single research funder deposits every single one of their grants, and you can go and find it through their API or download it through a spreadsheet. But there's not like a place where all the information is in a single place and it's nicely harmonized. So something that I did last year, because I have a UK focus, I had an original sort of UK focus, and then I expanded a little bit internationally. But something that I did is create a data set of almost 2 million research projects that compiled information from NIH, the NSF, UKRI here in the UK, Swiss funder, Swedish funder, the European Commission, etc. So I went to all these different sources and cleaned up the data, harmonized it to the minimum set of common information, and uploaded that information to a research repository for anyone to use. This actually, the community quite appreciated it at the time, and this was a massive need that actually got validated when probably you've heard of OpenAlex. OpenAlex received an almost £3 million grant from Wellcome Trust to essentially do this type of work at scale, and then doing the linkages between grants and publications. So basically, in the next couple of years, we should have a good open source alternative to go and find all the funding information from the major funders worldwide and how that funding links to outputs from that funding. Then I also work quite a lot with, again, like I mentioned earlier, OpenAlex. I don't know if people in the audience are hopefully some people will be aware of it or have worked with it. It's the largest openly available publication database. It's going to start indexing grants as well. And what I love about it is, well, when you work through the website, it has a really clean UI, very easy to use. But more importantly, they have a free API so that you can access the information programmatically. And what that allows you is that you can download every single information about every single paper with the metadata and automatically calculate what's called flags about each publication. So you can know automatically if a paper is led by, here, because I work in the UK, if it's led by UK researchers, but you could also do if it's led by researchers from your own research institution, if it has international collaborations, if it has industry presence, etc. And what that allows us is to calculate quite granular stats about the work that researchers, institutions, countries are doing. So you can know how often they work with industry, how often they work with clinical settings. And then if you enhance it with information from other places like Lens or with iSites or Overton, you can know things like how often are they cited by clinical guidelines or they're cited by patents, etc. Then I've been working quite a lot to enhance this open data, and that comes in the way of doing categorizations, or also I'll show you in a second something called topic modeling. But the simplest way of thinking of this is that sometimes when you do a search in a database, very often a lot of what you get out of it is actually not relevant, and then you need to spend a lot of time optimizing your keyword string. And some of the newer technologies help you with that process. But something I've been doing quite a lot is to use large language models to do very quick yes or no categorizations. So if I do a keyword string and then I pass all the papers or all the grants through a couple of large language models to have different opinions, and then that way I can make sure that I only keep the true positives in my data sets. And the perfect example that I found for this is a piece of work I did recently in which I used the field standard keyword string, the one that is commonly accepted. Like when you do bibliometric analysis, these are the keywords that you need to use. And then I actually used language models to clean it, and I managed to reduce by around 20% the amount of funding that was being displayed in the data set. So the amount of the amount of false positive that you can remove through processes like this it's quite large. And you can keep track of the quality of these categorizations if you have human labeled data sets. So here's just to show you that you can test this with different language models and how often they agree or not with human that are doing the categorizations. Here I actually have a funny story where a client last year did not trust language models to do this. So they decided to internally categorize 6,000 grants, and they spent around 3 weeks of a person's going grant by grant doing the categorization. And then I showed them that in 3 hours, we could get an 86% agreement with a language model. So that's then a discussion of, do you need 100% accuracy, in which case if you have 3 weeks, you go on and do it. But if you can live with slightly lower accuracy and you're happy with results coming, in just a few hours, that's a discussion that needs to be had. And this, by the way, I expect these numbers, this sort of greater how often LLMs agree with human raters to continue improving, because as you can see, there's been an upward trend until the last time that I tested this. This is for binary categorizations, but you can think of this for multi-option categorization. Say that you have a portfolio that you know that you want to categorize across 5 different options, and you've been doing it for the last 5 years manually. You can now set up systems to do this process automatically as new grants are coming in. And then when you do not have necessarily predefined categories, where you just have a really vast amount of documents or of scientific information, and you don't know what's in it, you can use a technique called topic modeling, which, in short, I'm going to keep this explanation quite simple. Basically, what it does is it grabs the text of those scientific documents, and then it clusters those documents based on their semantic meaning. So you can start with just text and end up with a map that looks somewhat like this, where any document that is close to each other, it means that they are semantically related, and then you can assume that they're talking about a similar topic. And because if you know the documents and you have the text, then you can use large language models to create automated descriptions, automated titles, or automated summaries of what each one of those clusters, each one of those topics are talking about. It's a way of very quickly visualizing and grasping what's going on across potentially tens or hundreds of thousands of documents. So this was the most technical part of the talk, and I go into more practical examples, because I've told you, okay, we can look at data from sources like OpenAlex, or you can get access to all the metadata, and then you can do these things with topic modeling to try to figure out what's going on in fields of research. What I really enjoy is what happens at the intersection between those two things, and I frame this like in the way of saying, like, does your research strategy need more research? For me, research is about asking questions, and I would hope that, in an ideal scenario, I think research performing organizations, there's a set of questions for which they should know the answer basically at all times. For example, what are the gaps in capability or infrastructure within your geography or within your field of research? What areas of research is industry more interested in? Who are the key researchers working across different areas? Or should your DI intervention be targeted or broadly applied to your field of research? Let me give you here an example of an analysis that I did, where this was for analysis on dementia research, which I don't know quite how this works in the US, but here in the UK, it's very common to juxtapose fields of research. Like, for example, you would say dementia research versus cancer research versus cardiovascular research. And what I'm showing with this analysis is that each one of those fields have subfields that are perhaps more similar to another one in the next broad biomedical area. So, for example, in dementia, I was able to show that some areas of research here in the UK were led by UK researchers 76% of the time, versus others were led by UK researchers only 17% of the time. And that told us something quite valuable about lack of infrastructure on a particular diagnostic technique here in the country. Likewise, some areas have 4% industry participation. So basically meaning 4% of those papers have someone working in industry, while some other areas is 10% or 21%. So you can go to these really granular descriptions of subfields of your areas of interest. And then obviously you can even look at the researcher level, like within topic one, and go and find who are the people who stand out according to different metrics. If you're doing like an interview campaign, or you're looking people for a peer review, or for your grant board, etc. I saw this post on LinkedIn. Here in the UK, universities are quite stretched economically, so there's a lot of discussion of how to prioritize different areas of research. And there's this man that I follow, also a consultant, that suggested a 2x2 framework, where you sort of quantify for your the different areas of your portfolio what's your level of contribution to that field, and what's your level of uniqueness to that field. And based on that, some areas where you can invest and expand, or collaborate, or maybe downsize because of the economic realities. And his approach was, his suggestion was quite qualitative, and I thought, I'm sure there must be a way where you can actually put numbers, where you can create a contribution score, a uniqueness score for every single organization operating in a field across the different areas in which they work, and then have this 2x2 sort of frameworks for every organization. Haven't built it yet. I'm waiting to see if someone pays me to do that. But something that is quite similar and that I've been using is looking at the semantic space that different organizations occupy. So if I plot where the documents produced, in this case by AstraZeneca and a university here in the UK, if I plot where they fall in the semantic space, I can very quickly identify areas where this university might be able to collaborate with AstraZeneca, for example. That's an example on just two, like a one-by-one comparison. I've done similar space for like a similar thing for whole fields of research to look at where different funders, what are the different areas that they occupy, what are the areas of overlap, who should they be partnering with, etc. Same approach can be used to look at what areas of your portfolio have been more productive than others. I think if you are lucky, you know every single one of your grants, what outputs they have produced, but that's something that it doesn't often happen, at least with a lot of the clients that that I work with. They have obviously the grants that they have funded or that they have in their portfolio, and maybe a whole list of the publications that acknowledge them. But that linkage between those two things is not always easy. So you can use, again, this semantic similarity to plot in blue the grants and in gray the papers, and then kind of do a visual comparison of what areas are more or less productive based on that semantic similarity. And I think this is the last example that I have, is you can also look at how are the careers of my researchers progressing based on metadata. So I do quite a lot of fellowship evaluations, for example, where you can see how often researchers used to work with industry before and after a fellowship, or how they expanded their international networks, or how the amount of funding that they've been receiving after the fact from other major funders, as a way of keeping track of career progression of the people within your portfolio. And this is actually quite easy to do. If you have unique identifiers from like ORCIDs, this is extremely easy. If you need to rely on name matching, it's a little bit more complicated, but it's once you have it, once you have done the necessary matchings, you can just keep track of every single researcher in your portfolio in an automated way going forward. So I've done, like I said, I've been working on my own for a couple of years. And I think the first year there was a lot of emphasis on standalone analysis, but this second year I've worked with larger organizations who actually want to build systems themselves and own the systems themselves. So I'm just going to show you a couple of those that use the same principles that I've shown in the last few slides. Everything I'm going to show you now relies basically or has some component of using large language models automatically through their APIs to automatically process information from publications, from grants, from progress reports, to create things like summaries, or to extract information automatically. I work primarily with funders, and I know, and I used to work in a funder, so in a research funder, so I know how often research progress reports are received. They are read once, maybe, and then they go and they stay in a folder and they are never used again. So having a way of automatically extracting information from those reports and then being able to quickly categorize and shortlist those progress reports is something that can be quite useful. And like I mentioned earlier, if you have a list of researchers' names, you can create quite quickly automated sort of profiles of the people in your portfolio. So with that in mind, one of the latest things that I've done is an automated pipeline to find and profile relevant researchers working in any area of interest. I'm depicting here something with numbers from something that I finished actually just last week, where starting from 130,000 publications, they'll have at least one UK author in the last 5 years. This was in a particular area of research. You can first shortlist the top 3 authors based on a series of bibliometrics. And then now we can do automated web searches where you can just send an LLM to do web searches for each one of those 3,000 authors and ask the LLM, is this a relevant person for the very detailed description that I give it for the project that I'm working on? And then you can go with those the short list of 300 authors and end up with a spreadsheet that has a profile based on online searches, keywords, scientific profiles based on summaries from publications, types of scores like in strategic and translational and innovation frameworks. And then, because this was for an interview campaign, create automatically 10 potential interview questions for the interview campaign. And this whole process, because I used to work in consulting a few years back, which I know would have taken weeks to end up with a list of 100 potential stakeholders for interview. And now you can go from start to finish in less than a day using these techniques. I've also been building bibliometric platforms for internal usage. So basically, organizations that do not want to continue paying, say, to Clarivate or to Dimensions to have a dashboard featuring stats about their own organization. And nowadays, because of open data, it's just very easy to recreate what these major platforms are doing. You can just find information about the papers from your organization through different repositories or from the progress report that you receive. You can enhance it with clinical guideline information from Overton or patent information from Lens, etc. And then you can just link it all together, and at the end of it, you can have, in the simplest version, a Power BI dashboard that shows just the key stats that you care about for your organization. And that can be automatically refreshed as data gets updated in the different platforms. And then the final example that I have is about a peer reviewer tool that I built. And this was a funny example because when I started building it around last year, I first looked at whether there were good alternatives. I wanted to know if this was going to be good business or not before spending quite a lot of time. And back then in the UK, there were not really I saw a couple of companies, but they had not a lot of presence in the UK. This past year, so many organizations are doing this type of thing, either because they've built the product, it's the main thing that they do, or it's something that they are tagging along to other offerings that they used to have. And all of these tools have used basically the same technology, which is vector embeddings or making matches between documents based on the meaning. And here what I'm showing as an example is, imagine that the gray dots are papers and grants from the ecosystem. The red dots are the grants for which you want to find peer reviewers. And then the blue dots are the similar papers in the ecosystem, the ones that are within a similarity threshold. If you identify those blue dots, then it's very easy to just compile who are the authors or who are the awardees of those documents, and then create some type of shortlist to create those reviewer recommendations. So yeah, this is how it looks. Very simple Power BI, where you can you can score the potential reviewers across different metrics, like are they a senior or a junior author? Have they received funding to do this type of work, etc. And this, I should say, can be used to find peer reviewers, but also to find collaborators or to find people for your grant reviews or to find faculty that you might want to hire, etc. Which brings me to conclusion. I think it's important nowadays to just try to continuously sort of refine and optimize methodologies and to try to stay at the edge of what's happening, because a lot of what I've shown today was literally not possible 2 years ago. In fact, some of the things that I've shown today was not quite possible like 6 or 9 months ago, because the capabilities of these language models just continue improving, and the sort of the quality threshold continues going up. So at some point, things that you would say, I cannot accept this level of quality just yet, maybe 6 months from now, the models will be ready. And something I tend to always say is that I'm actually quite optimistic about the future of research and research strategy and research administration, because we start to have these clear technological solutions for problems that previously seemed intractable, or that at the modern scale seemed quite intractable. And I think it's just a matter of time before these technologies are widespread across organizations. And yeah, I think everyone's life should be a bit easier once they are more used. And that's it. Thank you for your time, and I'll be happy to answer any questions.
Awesome. Thanks so much, Jorge. That was amazing. Cool. So if anyone has any questions, now's the time to come off mute and ask questions. Yeah, I will see if anyone is interested. Let me... Well, if there are no questions, a couple of questions did come through in the sign-up form. I'll just go through and check if any of these are relevant and see if anyone has any questions when I come back. So a couple of people asking for different different products that are out there. So you're obviously doing a lot of consulting, building these as one-off solutions, right? Do you have any kind of recommendations as well for other platforms out there? What's the best way for people to start getting there, to start visualizing this data?
So I saw actually in one of these questions that someone mentioned Faculty Insight from Academic Analytics, and I've had around a look, and it looks like they're doing quite similar things, but also expanded to some other areas. What I've seen is that most companies that are using or operating in the space will use the same sort of technologies, basically the same principles, a lot of semantic matching, a lot of processing information with large language models. And I think the key distinction for me that I would give to anyone when trying to choose what vendor you want to work with is the level of how bespoke they can make things for you, I guess. Because there's some really, really good platforms that work well for large amounts of clients, but I guess you need to wonder whether that particular platform is going to work as best as possible for yourself. And that's why I think, and I'm quite optimistic for platforms like Atom Grants or individual providers like myself, where we can be more agile, perhaps, at larger companies and provide better services, I think, than some of the larger companies, even if we have lower capabilities than they do.
Awesome. So I think there are a couple of questions about using data to find collaborators. So you mentioned that that report you put together of 300 faculty. Is that something that you can also do to help people find collaborators as well? Can you talk a bit more about that?
Yeah, definitely. So basically, if you can define a starting data set about the area of research that you are interested in, and that can be through a keyword search, or if you are aware of already, if you have 100 papers within that you know are relevant to your discipline, going from that to identifying who are the most suitable people based on your predefined parameters it can be done quite quickly, because like I've said, in the past, you would have gone paper by paper, looking at lists of authors, and then going to Google, and then going to their academic profile and trying to make these decisions one by one. Now you can give really clear instructions to language models and just send it to do that automatically for you, so that you go from basically lists of researchers that you would not have been able to process, like in the thousands, down to numbers that you can process manually and that are all high quality. So I can tell you that in my experience, this thing with the top 300 authors, our goal was to shortlist for around 50 interviews, and we're having a really hard time because the 300 of them are very relevant for the area that we're interested in. But yeah, that's something that can be done to find collaborators, competitors, to find similar principle, to find peer reviewers, to find faculty candidates for job applications, things like that. Anytime that you need to find stakeholders, either people or organizations, these processes really can help.
Awesome. This one's a kind of question relating to bias and open data and GenAI. So this person was specifically interested in, like, obviously AI has massive risks in terms of amplifying bias. Like, is there any way to limit that kind of the bias amplification? Open data maybe leans more heavily towards, I don't know, Western organizations or something. Like, what do you see in terms of like?
So actually, I would say that I think it's a bit the opposite. So if you work with primarily providers like Scopus, for example, they tend to be really, they have what they call these quality filters, which very heavily weigh research towards Western countries, Western institutions. And OpenAlex has the sort of, I guess, the ethos of we're open, we index pretty much everything, which means that there can be low quality stuff there, and you need to make sure that you weigh things appropriately if you are trying to do, say, for example, an evidence synthesis. But in terms of sort of that data filtering process, I think open data is perhaps better for these tasks than proprietary databases. In terms of AI, you are absolutely right. I think you need to be extremely detailed in the instructions that you give to the AI to make sure that it doesn't deviate from them or that it doesn't bring its own biases to the table. When you work with bibliometrics, I haven't, like, this could be a whole presentation on its own, but it's widely discussed and widely accepted that it's irresponsible to make, for example, hiring decisions or funding allocation decisions purely based on bibliometrics, because we know that certain types of researchers tend to be more favored when it comes to certain metrics. Some people get cited more than others, and because of prestige, for a number of reasons. So you need to be quite nuanced when you do this type of work. So yeah, just something I should have disclaimed. There's quite a lot of thinking that goes behind this type of work to make sure that we're not just blindlessly trusting what a language model says.
Awesome. Yeah, very important. This one's more of a general question, and maybe we'll finish on this. So the question is, how do you see research administration and the role of research administrators changing with the adoption of AI?
That's a very good question. I think within a few years, perhaps the outcomes will look very similar, but the processes will be entirely different. And the rate of adoption of these new technologies will be very, like, sector dependent and institution dependent, and perhaps even country dependent. But I think that eventually most people will end up using a lot of these tools in their day-to-day, and it won't be through sort of coding pipelines like some of the things that I've shown you today, because that's quite advanced. But I'm sure there'll be providers like Atom Grants or others that make complicated workflows easy for the users, and it'll just be there'll be new platforms and new tools. It'll be, if I had to bet, it would be mostly recognizable, but working with different tools.
Cool. Awesome. Well, I really appreciate the time you've given us today, Jorge. I'm just going to say a couple more words about what we're working on at Atom for everyone in the audience. But yeah, I just wanted to say really interesting stuff that you're working on. And, we're obviously thinking about how we can use AI as well to support research administration. And a lot of the stuff you spoke about today, we've been thinking about deeply as well. Using semantic technologies to actually just, we're looking at less from a kind of impact perspective on grants and more about identifying funding opportunities and then creating those profiles in the same way that you're doing for those kind of like collaborator searches. And then that map visualization was a perfect kind of example of what we do to actually match you with active funding opportunities, right? So it's about creating profiles for researchers and then connecting them with those funding opportunities that are out there. So yeah, super cool, the stuff you're working on, Jorge. If anyone's interested in learning more about how we can help your organization find more grants, bring in more funding, and generally engage with your researchers more, feel free to, you can book a demo by scanning this QR code here. Obviously Jorge is also available for consultations as well, so I think that's the best number, best email to reach him out there as well, if you are looking to build any custom workflows as well. So yeah, thanks again, Jorge. Thanks again, everybody, for giving up your lunch times to listen to us. And we are that's it for today. Thank you, everybody.
Thank you, everyone. Bye bye.
Cheers.